Look up. The air above us is a thin, volatile fluid, violently stirring to correct a massive planetary imbalance. Every day, the sun bombards the equator with intense heat, leaving the poles frozen. This thermal inequality breaks the atmosphere. Equatorial air heats, expands, and rises, creating low-pressure zones. Meanwhile, freezing polar air sinks, crushing down as high pressure. Wind is the physical reflex to this imbalance. It is simply the mechanical rush of air escaping high pressure to fill a low-pressure void. The atmosphere is trapped in a permanent struggle for an equilibrium it can never reach. The speed of that reflex depends entirely on the pressure gradient. A steep difference between high and low pressure acts as a heavy foot on the accelerator, generating immense mechanical force across the landscape. But the air cannot travel in a straight line. The Earth is rotating beneath it, forcing moving air to deflect sideways. This is the Coriolis force. It shoves rushing air to the right in the northern hemisphere and left in the southern hemisphere. Eventually, the inward pull of the low pressure perfectly matches the outward push of the Coriolis deflection. The result is geostrophic balance. This exact physical stalemate prevents the atmosphere from equalizing. Instead of a direct rush of air, the energy gets trapped in the swirling, rotating cyclones that drive our daily weather. Over thousands of miles, these physical rules organize into massive, permanent corridors of moving air, like the westerlies and the trade winds. Higher up, at the boundaries between massive temperature zones, the air narrows into the jet streams, turbulent ribbons of vapor tearing through the stratosphere at over 100 miles per hour. Down at the surface, differing heat capacities of land and ocean create extreme localized disruptions. In places like India, this temperature gap triggers seasonal wind reversals, monsoons, that dump staggering volumes of water onto the continent. These swirling, reversing global highways dictate the exact delivery routes for the planet's heat and moisture. To get a single drop of rain, moisture must be physically forced upward until it cools and condenses. Wind is the mechanical pump doing the heavy lifting. Sometimes it works exactly like a wedge. A dense, cold air mass plows into a warm, humid one, violently shoving the warm air upward along a weather front. Other times, convection takes over. Ground heat destabilizes the air, sending it shooting upward to form cumulonimbus storm clouds. Inside, vertical currents suspend millions of tons of supercooled water and ice, holding that immense weight until gravity wins, releasing torrential rain. Faster, more urgent tone. When this entire process organizes over a warm ocean, the wind extracts surface heat to build massive, self-sustaining cyclone engines. By the time a hurricane makes landfall, it delivers a devastating payload of trapped moisture. The wind dictates exactly where water falls and where it doesn't, drawing permanent lines between barren deserts, lush green habitats, and flooded cities.